to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Viktor Klang, who is a programmer, researcher, public speaker, and is currently Deputy CTO at Lightbend Inc. based in Sweden. Viktor Klang, welcome to Maintainable.
Hey, how's it going?
Doing great. Let's dive into it. So, given your experience in the industry, what do you believe are a few common traits of maintainable software?
So I think the most common traits of maintainable software is probably the ability to essentially change the code, but also having this separation of concern. I think being able to condense over time the code so that it more and more represents only what's needed. And one of the core things there, I think, is to try to get more to a declarative way of writing it. So more focusing on the what rather than the how, because being able to maintain it means that you have to keep the how equal throughout the system. So that means that if you're able to just state the what, then the how will be the same across a larger and larger code base, because that's typically how things go. Another trait is that the code should ideally not grow. It should grow sublinearly with the feature set. So if you're adding more code, like over time per feature, then you're adding lots and lots of complexity and things that can go wrong over time. So ideally, you should want to end up in a situation where you're actually removing and condensing and distilling the code base over time. If you're seeing the complexity levels of the source code grow linearly or even worse, like above linearly, then I think you might be getting into a situation where you're spending more and more time. I mean, fundamentally, maintaining a code base should not be about firefighting. If you're in that state, things are already bad. So I think maintaining a code base is really about evolving a system or an application to meet a changed set of requirements. It's not about just trying to have the ship floating.
Right, sure. And you were talking about a moment ago about declarative and specifically mentioned like the what, not the how. Can you give our audience kind of like a tangible example of like a difference there?
Oh, absolutely. I think, of course, it depends on the application, but imagine that you have some form of common set of requirements. Typically, when you have an application, you want to have a distinct or a very consistent look and feel, for instance. So that makes total sense to try to get as declarative as possible so that you don't have a sort of divergence of the look and feel, because that will just confuse people. So it's not necessarily only the look and feel for the end user. And in the case where you're actually writing APIs, your end user is actually another programmer. So it's more, you want to keep the look and feel consistent for your users. So trying to be declarative about that, consistency is key. And for more drastic measures, you might want to get into essentially doing code generation for generating APIs, for instance, so that you know that you have a standard set of how you present your quote unquote product to your end users. But it also goes into the other direction as well, like how you interact with other systems or other applications, trying to get to a common way of doing things.
Interesting. So I know that like some frameworks, like I come from like the Ruby on Rails world, and there are generators built in for like just having some consistency. Like when we're going to add a new database column or a new table, like this is how we do that. Or we're generating a new controller or a new model. Here's kind of what that looks like. And so here's how the automated test files might look like, at least as a framework to people to have some consistency. Do you see that as being pretty common in a lot of frameworks these days? Or do you see there's organizations that have to kind of develop their own framework because they're they're not leaning on, say, something like a web application framework like Rails or something.
It sounds a bit weird, but the way I want to think about programming is, what if we didn't have programming? What if we only had the real world and there was no virtual world? So how would you do things there? If every single new room that you visit could look vastly different and chairs would be used in a completely different way in different rooms, it would be very hard to orient yourself when you enter a new room and know what thing is used for what purpose. So I think the same kind of logic needs to be applied to software, because fundamentally it's just a virtual representation of something within the physical world. So having a shared set of expectations on things that you see is very useful, because if a thing could do anything, then what kind of assumptions can you make at all? Like, you need to do so much more analytical stuff to orient yourself. And I think everybody needs to pay that cost at all time. So it's not even something that gives you incremental value. It's just aggregate cost over time.
Another thing you had touched on is, another sign that something, maybe a piece of software is not being well maintained or has not been handled well. You maybe have a big mess because you're constantly firefighting problems. And people, that might be a subjective thing for different people. Like, what if you're on like a team where you're responsible for squashing bugs? Is that your job consistently? And does that mean there's a mess, or there are some like more tangible examples that might apply to developers that are building new features and maybe being responsible for like providing some operational support?
Really good question. In my preference, it's every single organization is different. Every single team is different. But I think fundamentally, rotating roles, I think in my experience, that is a good thing, because everybody gets to experience all sides of the story. So if you're only on the developing new features side of things, then you never see the impact that doing something in a certain way has on the maintainability of that thing. And if you're only doing firefighting, you get a very different view of the world depending on who creates your features that you maintain. So I think, fundamentally, what I've learned through my career is that I think it's really healthy to have rotating roles between developing features, even supporting, like, to your end users, doing end user support for your functionality that you're responsible for, to handling all the releasing of things or managing the iterative cycle of the development. From my experience, I think that is also useful because you get this sort of cadence. You know that I'm only doing this for 2 weeks, let's say 2 weeks. So if that's not my favorite role, then I know that there is a very strict time limit and it's not like 3 months or 6 months. So even if it's the most boring role, at least it's going to be over soon. You get this clear separation of concerns as well. Like, okay, so right now I don't need to focus on the feature stuff. So my brain can sort of let that go for a while.
Right. Out of curiosity, do you have, between those two types of scenarios, working on features versus being a debugger, kind of in that role, do you personally find yourself gravitating to having more of a deeper interest in kind of excitement about?
I think the answer to that question is probably, I am a maintainer kind of person. I like maintaining stuff, but when I say maintaining, I really mean it in the sense that I mentioned before, like growing something over time, seeing it changing the demands, or a certain feature didn't really pan out, or like learning from this experience, because ultimately creating a feature might be a day or it could be a week, but maintaining could be years. So I think if you're only set up the right way, and if it's something that you can grow with rather than you can sort of stress out about, I think it's much more rewarding to do maintenance work. But of course, I do a lot of new feature development as well. So I think it's a healthy thing to have experience of both sides of that story. Personally, I find it really hard to start with a blank slate. Some people, they love that. That's what really triggers their creativity, having essentially a limitless array of possibilities. Whereas I tend to work best in a very, like, the smaller the box, the more creative I get, because it's harder and there's not much to work with. So I need to get more creative. But I think that's just a complete personality trait kind of thing.
It's something that I, as a developer, also share. I think there was a terminology that I saw. I think it was written by the folks that run the Legacy Code Rocks podcast. I think they had an article talking about the differences between makers and menders. And as soon as I heard that word menders, I was like, that's me. I don't enjoy building new things from scratch. It's like never been my favorite part of the process. And even though that's what I felt like, that's how you learn how to write software most of the time. You don't usually get thrown into the deep end of some existing application. Although I would imagine most people's first job as a developer is getting thrown into the deep end of something that exists already, because you probably don't get the benefit of getting to start a brand new application unless you're at a brand new startup or something. So there's like an interesting aspect to, I think, software development education doesn't really talk maybe enough about maintainability and like what it means to go in and like take care of things. You have plumbers that deal with, your plumbing, but are those the same people that also install the plumbing from the first? You don't hire the same people. It's people that come in and take care of, improve things. And this has been an interesting thing that I found myself aligning more in the last few years, which kind of, I think, obviously kind of coalesces with me starting this podcast and wanted to talk about this stuff with people, because I don't want to think that I'm not alone. So that's good.
No, absolutely. And I think on that topic specifically, I mean, I spent quite a few years thinking about this topic from time to time, because it would be so interesting to see a software development sort of program where you get to work on the same code base for like 3 years. Like you incrementally work on the same code base, you add features, you have to sort of see what the consequences are based on what you knew then versus what you know now. And even like pulling people into your code base to do stuff, like collaboratively throw people into an existing code base over time. Because I've seen so many times somebody come straight out of school and the reality that they meet for their first job is so dramatically different from what they were prepared for. So it's almost like it's like a shock level experience. So I think having a more sort of gradual introduction to the life cycle of a code base would probably help in that aspect. But I don't know what schools are doing nowadays. So
yeah, I don't either. I didn't go to school for this really either. So yeah, it's interesting because we hire some people at my company that come out of boot camps and stuff, and they've had some experience of like collaborating with their peers on some projects or maybe doing some pairing or what have you. But they're usually working on some new apps for the most part. And when they start, we're like, all right, here's an app, we got to get this up and running. And we've been working on this for the last 6 years. And they're just like, whoa, this is huge. And like within like a couple of weeks to a month, they feel way more comfortable in it. But there's still like this immediate shock of being like, oh no, I don't want to break anything, or I don't understand what is all this stuff. And there's a lot here. And it is interesting. I think you were touching on the idea of like an education system having something like that's an interesting idea of having something you can kind of gradually work on, see the consequences of some of your decisions, but also thinking about how real teams probably have people coming and going. And so like having people come into a project for maybe a while and then leave, and then someone else comes in and dealing with someone else's previous decisions and knowing that that's a part of the process. And then maybe they can learn some of those skills of learning that, which kind of leads into one of my next topics, is like, thinking about what technical debt is. So, and like a lot of people sometimes will, or I think I've noticed in some people in their career will refer to things as technical debt when they're referring to someone else's code that they don't agree with or something. And like, I feel like there's a maturity level thing that happens with developers over time. Like you get to have more understanding or more empathy towards the previous developers and not knowing what their constraints were. But how do you and your team define technical debt?
So my personal definition, and I haven't really penned it, but I think my personal definition is that that what you're doing is a stopgap solution. That the cost will actually increase over time. So if you stretch it out over time, it's not a net positive addition to the code base, basically. Then, of course, depending on how good that solution is, it might be like, yeah, if it's 10 years, yeah, that's fine. We're not going to we're not planning to not fix it for 10 years. But if it's really something where if we do this now, but we haven't fixed it for real until tomorrow morning, then a lot of other stuff is going to break. So it's a complex thing. And I think you're completely on the point when you're saying that tech debt really means a very different set of things for different people. It's completely right that when we see a solution, we don't know instinctively what the constraints were. But on the other hand, that also puts it on us to be clear about what our constraints are when we write the code. Because if those constraints are lifted down the road, then somebody might actually come around to that piece of code and be able to improve on it. So I think that is a really good use case for how you use comments in code. I use that all the time. I very liberally use TODOs and FIXMEs because I want to keep that information as close to the code itself. So I really want to have that. So if I made a trade-off here, I want that to be very tightly coupled with why.
That's interesting. So a lot of your code has to-do comments that are kind of outlining why you decided to do it this way. Sometimes I see to-do, like we take on a lot of existing projects, and one of the first things they do is look for to-dos or fix-me type messages in the code just to kind of get an idea like, all right, so maybe someone else has hinted at some potentially problematic areas. Sometimes we get the benefit of someone actually maybe explaining a little bit more versus more often than not, I see is someone might do that, but it's more of a like they're kind of just admitting that they're embarrassed about a piece of code. And like this should be cleaned up, but there's not really a lot of explanation beyond that. So I think that's interesting to have that kind of approach to explain yourself at that point and like why you're doing it this way, what's the trade-off, what you considered or what have you. Is that tend to be a pretty lengthy thing or just like a couple sentences or something?
Yeah, I think it's a problem when comments become too long because programmers will tend to just gloss over it. It just becomes background noise. So I think if you're diligent about it, then comments should either be in the case of documentation where it's clear that this is documentation. But I think to-dos and fix-me's should be very visually distinct. So I try to keep them on one line so that you don't conflate them with actual documentation. To me, if you're doing this thing right, then having to-dos and fix-me in your code base is a sign of good health. You have developers that really document what they know about something because to me, the worst thing is if you get into a code base and there are no comments like that, then you need to derive all those conclusions yourself. Like, is this performance critical or not? Should this take into consideration something that it currently doesn't? And if that is all sort of left to the reader, as an exercise to the reader, then it's more of a test, really, than trying to help your coworkers and future colleagues.
I think that's a really good idea and a good point for people to kind of reflect on, I think, for those listening. Out of curiosity, what do you believe developers often get wrong when they're using or throwing around the term technical debt?
I think it's probably what you mentioned, that when it's code that somebody don't understand or uses something that is now not considered the thing to do anymore, or I've maintained Codebases for like up to a decade, being an active part of maintaining Codebases up to a decade. And I think a very common thing that you see in code is what I call sort of sedimentation. You see like this area of the code belongs to the foo era of this code base where this thing was all the rage. And you know what I mean? It's like you have this sort of idioms or parts of libraries that you use or just styles. To me, that is both a sign of health and a potential sign of trouble, because it could be a sign of health in the sense that, hey, it just works and there was never a reason to change it. But it could also be a sign of nobody understands this anymore, so nobody dares touching it. So I'm actually leaning towards code should always, especially code that is not test code. So feature code should always be subject to change. I think that is a sign of health. So I've tried to apply the what we call sort of the scout rule, which is leave the campsite in a better shape than how you found it. So whenever you're investigating and you're searching for a bug and you see something that looks out of place or could be tidied up, I think it's just a sign of good faith to sort of, hey, let's just do it while we're here and we'll leave this in a better state than how we found it. The good thing about it is, I mean, of course, it can be frustrating to do it all the time, but over time, if you do this as a habit, then you're always going to have a better code base the next day than you had the day before.
Right. I think that's a good idea there for people to reflect on. Something I think we need more of in and outside of our code. That's probably everything we're probably interacting would probably benefit from that, but definitely for ourselves as software developers. How have you seen teams start to make transitions to making that seem okay? Because I've talked to some developers. I've even seen people on my own team at times say, well, I don't have time to do that right now. Or even I would say maybe worse, see that someone else is maybe sending a pull request with some things that were outside of maybe the specifics of that feature request that they're working on, but they've done a little bit of cleanup and they're like, well, why did you spend your time doing that? Like, that's not as important as this like deadline or something. What would you say to people like that are listening that might be on either end of that scenario?
So ultimately, it's a cultural thing, right? And if you have identified that this is a potential cultural issue in your team, I think it's better to just have a conversation about it. So would you be upset if somebody sort of cleaned the coffee table at work and put away the used cups or mugs? Like, you wouldn't. Like, that would just be somebody being nice. So I think we should view it the same way. Like, somebody saw something being out of place or could be made nicer, and they did that without even being asked. So they were being nice, so let's give them some credit for it. So, I mean, of course, you can always have a routine for it. You might have a prefix on your commit for it, say that this is just tidying or whatever you choose, whatever word you choose, but so that at least if you're sort of scrolling through the commit log, you see that there are these commits that are incrementally improving things.
That's an interesting idea. I hadn't thought about that as an idea. We do things like, like features and, hotfixes, things like that and such, like, but thinking about just having that be more of a regular thing of having some of those little small things you do and where do those end up and like when you commit that stuff to your code base. I like that idea.
But I think also your question really points out something important. So how can I find time to do this? And I think the realization is that even if you do the smallest thing, at least that was fixed. So if you always need to allocate the largest chunk possible of memory, then you're always going to find it hard to find an allocation spot for that. But you can always get 5 minutes here and there to just incrementally improve things. And then, of course, if there is something huge that you need to do, like a fundamental refactoring of something, then, of course, that is a more involved effort. But that is also an opportunity to bring in your juniors, give everybody a shared sort of tidying day or where everybody help out and tidy the place up. So it's also could be something which is like a team building exercise.
Right. I like that idea too. It's a good one. I might reflect on that one a little bit with my own team here. Out of curiosity, how have you seen teams effectively manage like things like technical debt, the things that they know that like, all right, this is something that needs to come up at some point. You mentioned like there's to-dos, things like that might hint at some point. But from like a process perspective, is this something that you see teams that are, whether they're doing, some flavor of Agile or Scrum, or like this is something that becomes like a story that they need to work on? Or is this something that, what have you seen work well in your teams or the people you've worked with?
Really great question. So I've never really seen it work when somebody wants to schedule a story. Like, as a developer, I want my code base to be healthy, therefore we should fix it. I've never seen that work. Because ultimately, if you need to create that card, it means that you cannot really affect your priorities. You need to sort of pitch this to somebody external, and they're always, like, invariably, they will have more important tasks to do. So I think the only way of increasing the chance of success is to have it as a standard routine. This is not something which is a part of a distinct or is its own task or is its own story. If you're getting into creating a new feature that touches an area of the code where there are to-dos, then I think it should be considered whether those to-dos should be absorbed into the solution for that thing as well. So that's my experience, at least. And I think fundamentally, it's just one of these things where it just needs to be almost indivisible from creating features or fixing bugs itself. That's also what I mean. If it's always like a 5 or 10 minute thing, then it's never a big deal. And it always brings value in the aggregate. So I think it's a win-win. Like, it never takes a lot of effort or takes a lot of time from what you're trying to do, but it's going to increase over time the rate at which you can produce value. So it is going to benefit the product organization in the long run, incrementally, and it's also going to give you a better sense of progress. And I'm probably going to go off on a small rant. Ultimately, whenever you're dealing with a person that is doing something, motivation is the key thing. Over time, you need to have motivation be at least stable or progressively improving. So how can we create code bases, or what do we need to do to create code bases where our motivation as the developers and maintainers of that code base is at least staying around the same level or is even getting better? And I think there are some core things to this. So one, if we're always going to get into a better code base, then clearly we're going to feel better and better about it because it's always going to feel better. But it's also, I have tried to have a policy which I call it sort of zero known defects. If you can get into a state where you always fix all known bugs first, then whenever you work on a feature, it means that there are no known bugs. And just knowing that everything is working as intended, and now I'm going to make it do some more awesome stuff. That is a great feeling. I think it's very hard to stay motivated if you're feeling like everything is on fire around you, and I'm just going to add another thing that could catch fire. So whenever possible, try to remove all sources of, and when I say bugs, I mean things that are unforeseen error cases. So for instance, if you have a lot of runtime errors where like null pointer dereferencing or like stuff that really, it's just no fun. Like, it doesn't add value to anything. The user will feel like the system is buggy because it's just throwing these sort of random errors, and they're not fun bugs to fix either. So it's really a lose-lose scenario. So whatever you can do to sort of remove the common errors, the common unexpected errors, that is a huge win. So like one example that we did 15 years back is we created this sort of online system, and whenever there was an unknown error, we would capture all related contextual information about, like, where did it happen? Was there a view attached to it? How did that view look like? What input data was added, etc. And just sort of take all that data, ship it to your issue tracker immediately, open a new issue about it. And then what we did as well is we did deduplication. So essentially we created a composite hash of the error so that we could know the frequency of the error and essentially the distribution over time. So this is a new error that's suddenly hitting a lot of people, and it's something that we didn't know about. And what was interesting about that feature in particular was if you have essentially a prioritized, it does become a prioritized list of the errors that you now know are frequently encountered by people and you have all the contextual information that you need in order to fix it, then you can always pick the lowest hanging fruit. And if you just stay on top of that, then eventually it will be empty. And then you have no known bugs, right?
Nowadays, what sorts of, I'm assuming, we have a lot of software tools these days that can help us kind of aggregate those things for us. Do you find that teams are effectively able to kind of use those tools and just try to continue to stay on top of that and continue a no known defect policy?
I think it really varies. I think the downside is that a lot of these tools they're not mission critical tools. They're supporting tools. And I think if you spend the majority of your time just here and now and fixing the immediate things, then staying on top of the sort of auxiliary tools, the supporting tools, is hard. So for the supporting things, just keep it simple. Like, it's better to have something simple that works than trying to allocate that large chunk to just make a really good solution out of it, but never getting the chance to actually do it.
We'll be back with my interview with Viktor in just a moment. Hi, it's me, Robby. I wanted to take a quick moment to thank you, yes, you, for making time to listening to Maintainable. If you're finding these conversations valuable, please consider sharing a link amongst your peers on social media. Or maybe even consider writing a review on Apple Podcasts or Stitcher, or if you have some chalk, maybe write it on your nearest sidewalk. Also, if you know someone in our industry who I should be speaking with on Maintainable about these fun topics, shoot me an email at robby@maintainable.fm. And now, back to our interview with Viktor Klang. How did your early career shape your view on software development?
I think in a lot of ways. So I started my higher programming education around the year 2001. So this was sort of peak bubble. And when I graduated in 2003, this was sort of like peak bubble burst. So I entered work life when a lot of people were unemployed. There was a lot of disillusionment of the internet and software. And I was lucky. I managed to secure a job straight out of school. And I had the huge benefit of having a boss that really handed out responsibility and gave me the room to choose what I believe was the best solution for something. Of course, I mean, we're always going to make mistakes and learn stuff. And I think the key is how you as a manager handle a junior's first big mistake. Are you going to essentially try to limit their responsibility in the future, essentially saying that you couldn't handle that responsibility, therefore I'm essentially capping the amount of responsibility that you're ever going to be given? Or are we going to try to learn something from this? I made tons of mistakes, small and large, but ultimately I was able to grow and get more responsibility and become more involved in stuff. And I think just having the right kind of organization and being exposed to varying pieces of a system, not really getting locked into something, and being able to essentially roam around a larger software ecosystem exposed me to a lot of stuff early, which I think gave me a lot of perspective on how things fit together. And especially when we talk about maintaining software, it's almost always about integration, because when something grows and changes over time, other things around it are impacted by that change and that growth. So how we connect the systems together also is put under pressure and is tested to how stable and robust and how able that is to evolve. So not being sort of cast into this sort of role where like you're only doing back-end development, or you're only doing database management, or you're only doing the views, being exposed to all the sides of software development. I'm definitely not going to claim that I'm good at doing front-end work, but I did front-end work, and I learned that I wasn't good at it, but I knew what made it hard. And that also if you get experience, you get a different perspective. And I think what we need is developers having more perspectives and more understanding for what other kinds of developers or other professionals do and why it's hard and what they need to take into consideration. Because ultimately, it's all about collaboration. It's very little software that we create in isolation, and we can keep the master drawing in our own head, and that doesn't impact anything to the negative. So, yeah.
Yeah, I think you make a good point there in terms of getting that exposure. And I'm glad that I feel very fortunate that my first projects were more front end focused in a lot of ways. And I learned a lot of pain from that because it was not anyone can seemingly learn HTML and CSS, but to make sure, especially back in that area, it was a lot of dealing with a lot of different browsers, there were a lot of challenges back then and for front end development. And so to know that there was people that felt like they could push through that and have good patterns for that and wanted to make that world better for themselves. There was a point where I was like, I'm so glad that there's people to do that. And I still have this like affinity towards people that do that. I meet some developers that are new to this career and they're like, well, that's like the easy stuff, right? I'm like, no, like that, like the fact that they make it look easy is like, they've solved so many hard problems there and they're like wizards. And like, I am paralyzed when I see some CSS files now and I'm like, I'm going to break something. I feel more nervous about making CSS changes than making like database structure changes. And that's kind of funny, but it is a reality. I'm like, I don't know how to test everything across different devices and browsers. And like, there's people that know way more about this stuff now. And I'm so glad that they exist. So I have that. And I see people on the team. I really appreciate those people that are focused in those different areas. I think it's helpful for people to have that, go through that transition state. So getting some exposure. Let's say that there's a couple people listening that are, maybe they're a senior level type developer and they've got some new junior people on their team. And maybe they're trying to figure out how do we share some of this responsibility and decision making with the juniors so they have the freedom and they have some time to go off and try things and experiment, potentially break things, but know that that's going to be okay. Any advice you could offer to those people on how to navigate that well and not be too worried maybe about someone, making too much of a mistake?
I think it sort of varies depending on what the use and sort of what you're trying to do. Of course, the cost of a mistake varies with the project. But I think I tend to say that I value integration tests over functional tests over unit tests. So if the only tests you have are unit tests, then you don't know if your thing is actually sound from its outside perspective. And if you only have functional tests, you don't know whether it's going to fit into the context of where it's going to be used. So I value integration tests first, and then you write functional tests, and then unit tests are great at narrowing down where a bug can hide. It's perfect for that. It really sort of draws the boundaries of boxing it in, where essentially creating small failure zones within your code. And it's really good for rooting out bugs. But from a product maintenance point of view, if you have really good integration tests, then you can afford for your junior to try a solution out because they will see why that integration tests fail. And I think from like a human psychology point of view, we tend to be terrible at taking others' experience at sort of face value. Like you can tell somebody like, don't do that, it's bad. I know, I have the scars, I have nightmares. But if we can create safe zones where they can try a solution out and see why that would fail, then they can draw the conclusion themselves. Then it becomes more of a conversation between two colleagues where, okay, so we have this thing we need to do. How do you propose that we fix it? You can discuss the constraints, but ultimately, a programmer is not somebody who writes code. Like saying that a musician is somebody who plays an instrument. It's such an oversimplification that it doesn't really make sense. We want to solve problems. So if we're problem solvers, then we can talk about problems and we can discuss solutions without even writing a single piece of code. Like, how do you even know what code you should write if you haven't even started to solve the problem in your head? I think a junior and a senior can have a very long, extremely helpful conversation about trying to get to the root. Okay, so let's not discuss root causes or root problems. But I think a lot of times when you think that you're talking about the problem, you're actually talking about a symptom. If you start to examine the problem a bit, perhaps it's not really the problem, it's really a symptom of another problem. The most successful programmers I know are the ones that tend to write the fewest amount of features, because they draw these sort of connections like, yeah, they can just use that feature that we already have and they can get the same benefit out of it. Or they drill down like, why do you need this feature that you asked for? Yeah, well, we needed to send it to this other team over there. And then they go and talk to that team and say, okay, so why do you need this report? Well, yeah, we can't see that data in our side of the system. And then the real solution is, well, we just give access to that other team and we didn't even need to write a single feature. So ultimately, I think it's really about trying to get to the place where it's not necessarily about the code itself first, but it's really about how we think about things and what kind of trade-offs that we're willing to make and what side of things that we're willing to land. Like, are we willing to go sort of fast and loose and break a few things, or are we willing to be more cautious because that makes sense? And I think it's more about sort of the collaboration between the different programmers on the team.
Some really good suggestions there, things to be mindful about as you're navigating that between different developers of different levels. And I was just thinking about you were touching on, like, are you people too often focused on a symptom of an underlying problem? And so I think that's a good thing to maybe even ask yourself. I just had this mental image of like, I want to throw that up on like our wall as like a little thing. Are we talking about a symptom? Just to remind ourselves that like sometimes we just need that, like someone needs to hit us with that question. What few traits do you look for in developers, especially maybe budding developers that are coming into this career? Are there some traits or values that you're looking to find in these potential hires?
Yeah, it's always a tough thing to evaluate potential, because that is fundamentally what we're talking about. Because of course there are other professions like this, but I think being in software, and especially doing software development, is a very much a learning experience from day one. I learn new things every day. I make mistakes every day. So I think it's more about trying to find somebody who's curious, wants to learn new things, can handle failure and can be sort of guided through it and is willing to sort of learn from failure. Because, I mean, ultimately we need to take in new information every day. There is lots of noise to sort through. Like, lots of people are going to give you advice. They're going to be conflicting like 99% of the time. And I think potentially so hard to see in somebody. I think it's also about how well do they know themselves and why they want to do this. To me, I had this sort of almost eureka moment when I realized why I was a maintainer kind of person. It just turned out that the common thing in a lot of stuff that I enjoy doing is finding things. And when I identified that sort of the common trait that sort of triggered my motivation, then I can use that actively. If I can turn something into a finding exercise, then that gives me some extra speed and some extra motivation. That helps me to sort of push through, because a lot of problems are going to be problems where you're stuck. It's almost a common thing to feel like, hey, it's sort of this sort of being tossed between I'm the smartest person on the planet versus how am I not able to figure this very simple thing out? And being able to reconcile that within yourself, this sort of being tossed between these two, I think that is a real challenge. But I think it's also about the people that you meet when you get introduced into your career. As I mentioned with my career, being able to grow, being able to take on new responsibilities, being given the benefit of the doubt, having a controlled environment where where failures can at least, like the blast radius can be determined beforehand. Essentially, we're going to make mistakes. Having a good team around you that recognize that and aren't sort of like, oh no, we got a junior on our team. How can we work with this new person so that we can make things even better?
How can we help pass on the baton? You're bringing in someone to help the team, and so trying to find someone that could be a good value add. But you go back to, you made a good point that it's really difficult to hire for potential with someone that may not have a long track record yet to kind of reference, and someone that's in a hiring position myself. It is a really difficult thing to kind of navigate. And some of the things that I've tried to do is really dig into some questions with people just to see how introspective they might be, just to see like if they're thinking, if they have some sort of like self-growth mindset of some sort. It might come in a lot of different flavors. Sometimes you talk to people and then like you throw a question that's like, what are you on this big planet working on improving about yourself, And if they have a very, very specific question that's like very, very technical, because I think you want to hear something about they're working on improving their testing capabilities. I'm like, did you hear the question? It's like, maybe, and then I always worry that I'm just asking the wrong question. But I second guess myself. That's the thing that I'm working on. But it is an interesting challenge.
I just realized that one of the most profound realizations that I had about team dynamics and the potential of developers on a team was when I left a team after a very, very long time, like almost like 7-8 years. And the other people on the team suddenly had a room to grow into. When you have a team and somebody leaves and you don't necessarily add somebody immediately or add somebody with the exact same characteristics or skill set or whatever, you're really giving the other members a chance to pick up new responsibilities, or suddenly someone else is the most knowledgeable about a certain piece of code or a certain subsystem, or has better connections with the users. Or it was just a very profound thing to almost realize that the best thing that you could do for that team was not to be in it, but not for the sake of you being sort of detrimental to the morale or anything, but just because there wasn't enough room to grow in for certain people. And if you don't have a lot of turnover over time, and if you have a very stable team, then you might actually be crowding that plot of land. The plants can't grow anymore because they're already occupying all available space.
Yeah, you're blocking their sun.
So yeah, that was also really profound, and I didn't think about it at all. So sometimes perhaps it's best to remove the DBA person or the really seasoned veteran from the team just to give people more room to grow. Your mileage may vary, but it was just one of these things where sometimes that might be the right thing to do.
For those listening, if you've been around in your job for a really long time and you're starting to wonder if there's some grass is greener, it might be greener for your coworkers if you go get a new job. So maybe you're not the problem, but you might be. All right, a few last quick questions for you. What non-coding related book do you find yourself most often recommending to people in the industry?
To be extremely blunt, I recommend research papers because, and I think I can make the parallel again to the allocation problem. I think it's over time, if it takes you a couple of hours to read a paper, and even if you don't understand, I never understand things the first time I read them for sure, but it's of incremental value add, and it's much more condensed. A lot of times for books, either I find that there's just too many pages I'm reading, and it's like, yeah, well, can I get sort of the highlights, or can I get sort of the remove words that that doesn't necessarily add to the story? I tend to really recommend read papers, read different sciences. Like I read psychology and physics and maths and computer science and electronics and whatever. And it's just really small pieces. Like you don't even need to read more than the summary. And if the summary doesn't give you any enthusiasm around it, then at least you know that. But I tend to want to allocate things in small sort of bite-sized chunks. But that's just me as a person. So it's really hard to sort of give a really blanket, but that has been for me a really valuable source of knowledge, because everything, it feels very cliche, but everything is connected. So if you learn stuff about psychology, then that relates to your coding work around your team and how you interact with your users and stuff like that. And if you learn things about physics, you'll learn about communication and how fast you can communicate across distance and how causality. There's just so many things that will relate to what you're doing if you're just zooming out a bit. So I think that there's a lot of stuff that you could read about that you would find interesting and you could actually have a use for in how you think about your work and the software. And
for those that might be listening, myself included, that don't read research papers ever, if you were to make a recommendation for a place to go search through some sort of data set of that, where would you recommend? Go look at.
What I don't like is recommending people reading these sort of like, these are the most important papers the past 100 years. You should also read them. But I think in order to get into something, you should do something that will be rewarding for you as soon as possible. So what I would recommend is, what area of things interest you? And is there current research on that topic? Who does that research? Just search on Twitter or what have you for some papers. I mean, typically you can find stuff about that and follow them. Follow the researchers, ask questions. I believe that they love that people read their papers and ask them interesting questions. So I think that would be my preferred way to start. And then when you want to read the classics, you will know what the classics are at that point, and then you'll have a lot of value out of when you get to that point. But stay motivated. Learn about stuff that you like right now.
And where can listeners best follow your thoughts on software development online?
That's definitely my Twitter feed. It's a very varied feed of me either being frustrated about my daily coding thing or having this sort of eureka moment, relinking an interesting science article or something that I read. So I'm trying to sort of have that as my daily feed of thoughts.
It has been oh so delightful talking with you, Viktor. Thank you so much for joining us on Maintainable and sharing your thoughts.
It's been amazing. We could probably talk for another 2 or 3 hours.
I might have to have you back for another topic at some point.
That would be awesome.
Thanks again, Viktor.
Thank you.
Maintainable.